Welcome back to LikeTech. I'm Jim Jensen, and this is the Expressway series Deployment and Basic Configurations, Part 6. Basic configurations continue for the internal DNS. So come along with me as we configure LikeTech. Now that we've completed the external DNS record configuration, we can proceed to the internal DNS configuration. Just as an FYI, I do not actually have 4 Expressway E's in my lab. I was just doing this as a demonstration for you. My lab is limited and I don't have multiple data centers, so this is just an example for you. We will be using this SRV record right here that's pointing to Expressway E. The other ones do not really exist. So let's move over to the internal DNS configuration. So let's review our DNS settings for Expressway C. We will go to System, DNS. We will note the system host name is Expressway-C. It is in the domain of liketac.com, and I have a search domain of liketac.com too, which is not really necessary. If you have other search domains that you want to look under, that would be applicable. So let's go over to our DNS server. And our Windows DNS server has a zone called liketac.com. Again, for split brain DNS, we're going to have a liketac.com zone on the internal DNS server and our external DNS servers on the internet. When I look in this zone, liketac.com, for A records, I do not see an A record for Expressway C or Expressway E. So let's add an A record. We go to Action, New Host, and the A record is Expressway-C, and we note the fully qualified domain name is now showing us expressway-c.liketac.com, and I will assign an IP address to that of 172.16.20.2, which is the interface of Expressway C. I'll add the host, say OK. And now we note that we have a new A record for Expressway C in the Windows DNS server. Let's go over to our Expressway E, do the same thing. We will go to System, we will go to DNS, and we note the system host name is Expressway E, no dash, and it's in the LikeTac domain. So let's go back to our Windows DNS server. Let's add another A record. Go to Action, A record, Expressway E is the host name, and again we note expresswaye.liketac.com is our fully qualified domain name. We're going to add the IP address 172.16.20.248, which is the inside interface of my Expressway E. Since I am doing dual NIC, I need to point to the inside interface. If this was a single NIC, I would be pointing this A record to the outside public static NAT IP. I'll add the host. And we see that it's added successfully here. Going back to my Expressway C for a moment, we can do some verifications that these A records are now working. I can go to Maintenance, Tools, Network Utilities, and DNS Lookup. On the DNS Lookup tool, we can enter in that fully qualified domain name for Expressway C. Expressway-c.liketech.com. I'm going to tell it we're looking for A records, and I'll do a lookup. And you notice that I misspelled the host name, so it doesn't come back with anything. So that's a good verification. So I'll correct my spelling and make it the correct spelling for the host name. Do another lookup. And I do get the return of that A record. If I wanted to verify my E, I would just change it host name to expresswaye.liketech.com. And that gets resolved too. By the way, it's very important that the Expressway E FTDN gets resolved with an A record, because later on when we create our zone, one of the requests in the zone for the MRA is, what is my Expressway E peer fully qualified domain name? I'll enter that into the zone, and Expressway C has to be able to resolve the FTDN to an IP address so that the zone can come up. Another significant record we should verify also with the Expressway C is the IP address of the inside interface of Expressway E, 172.16.20.248. This is going to be a PTR pointer record on our internal DNS server. We're going to do a lookup for that. And we get a pointer record returned to us that shows us expresswaye.liketech.com. This is important for us because when Jeff comes in and says, I need a request of a configuration file or any other piece of traffic that I need from call manager or IMP, those UC servers are going to respond with the necessary information. But before Expressway C can actually send it to the Expressway E, it's going to set that packet aside. It's going to do a reverse lookup for the IP address it knows about for Expressway E and get back a response. It's going to take that response, attach it to the packet, and send it across the traversal zone. When the Expressway E receives any traffic on the traversal tunnel, it's going to open up that packet, look at the FQDN that's in the packet, that response we just got here, the expresswaye.liketech.com, and check the certificate on the server search to see if that expresswaye.liketech.com can be verified on the certificate. If it's there, then it will permit the traffic to go out to the internet and to Jabber, and then Jabber will know how to register and log in to those UC servers. If this response is incorrect or missing, then that traffic that gets sent to the Expressway E will be dropped. So this is a significant DNS record that we should also have. Up to this point, we have deployed external DNS records with the A records and SRV records for the Expressway E. We've created a couple of A records for our Expressway E and C on our internal DNS. And we've made a lot of to-do about why these are important, why DNS is so significant to a successful MRA deployment and using the MRA for our Jabber client and WebEx apps. So let's just have a little segue here on the importance of DNS records and getting them right. The first thing we need to know is that once I create my A records with the correct information, I will be able to generate CSRs for certificates and have them signed. And when they get signed, the SANs, or the subject alternate names, have to have the proper DNS names for our servers. So that's one reason why we want to get this right the first time. The other is how the Jabber client and the WebEx client discover their services. If we look under the hood, we'll understand more about the client and why it's important we get the SRVs and the A records correct. When I launch my Jabber client, for instance, it goes through a series of SRV lookups. Actually, the first thing it does, the Jabber client's going to ask the operating system, Windows, Mac, iOS, Android, what is the IP address of my DNS server? And the operating system will reply back to Jabber and say, here's your DNS server you can use for any queries you have, application. And then Jabber is going to say, thank you. Now let's try to find my SRV lookup called Cisco UDS. That's the very first SRV record that the Jabber client or WebEx app is going to ask. It's going to assume that I'm on campus, I'm in the local area network, and I need to find my call managers. And that's what the purpose of the Cisco UDS record is. As we can see in this Jabber planning guide, we have some internal DNS records called Cisco UDS. The server host name that it's pointing to is equal to like cucm3.example.com. And then there's a second one, cucm2.example.com, etc. As the SRV records are discovered by the Jabber client, in this case the Cisco UDS, once Jabber discovers that there's a UDS record and it's giving it a host name and domain, it's going to say, hey, what is the A record lookup for CUCM3 or the A record lookup for CUCM2? And the DNS server will respond and give the appropriate DNS to IP resolution. If that happens, then Jabber is going to stop right there. There's not going to be any further SRV lookups. It's satisfied that it's on the local area network and it should be able to connect to the call managers from the SRV record information you provided it. Now, if I'm not on the local area network, I'm not on campus, I'm out on the internet somewhere, perhaps I'm at Starbucks or at my house, and the Cisco UDS record is not discovered because they're not on the internet, a Cisco UDS SRV record would point to a private IP for the CUCM3 or CUCM2, and that would not be routable on the internet. So when we do the SRV lookup for Cisco UDS and we're outside the network, we won't find those SRV records, and you'll see it in the logs saying that DNS resolution failed. So the next lookup is going to be CUP login. We have deprecated CUP login lookups for Expressway purposes. You may need it still for on-premise. And then the third lookup is going to be our collab-edge SRV record, which will send us back those Expressway EA records that we configured in the previous video. So that's what's happening under the hood. If you understand the steps that Jabber is taking to try to get to the network, then you'll understand how the DNS is significant for you. So if you have a failure, you can go through this process of, looking up the SRV records for Cisco UDS, look up the SRV record for CUP login, look up the SRV record for collab-edge. If I'm not getting any of these resolved, then I need to start focusing on my operating system and the DNS IPs and what's happening there. So let's get off the soapbox, segue back into creating our SRV records and A records. Now that we understand the significance of having good A records and SRV records for our expressways, we'll come to the unified communication servers to add call managers. But before we add the call managers, what SRV record or what A record should I use and what's the requirements? Prior to 12.5, there was a requirement that you be able to resolve your Cisco UDS SRV record from the Expressway C. Some customers were not able to do that, and you had to create some kind of pinpoint subdomain so that the Cisco UDS record could be discovered by Expressway C and point it to the call managers so that service discovery could be happening on the Expressway C. Since 12.5 and beyond, we're not required to use the Cisco UDS SRV record anymore, only that we should have the A record for the call manager in our DNS. But there is a caveat, or a requirement rather, for that, and that is that your call manager server must be a fully qualified domain name. Let's look at the call manager right now. We'll go to System, we'll go to Server, And we'll do a find on my server. And we can see cucmpub.liketac.com is my fully qualified domain name. And if we recall from the previous video, we were looking at that DNS server. And in the DNS server, we do see cucmpub. It has a host A record, and it's pointing to the IP of that call manager. So let's go ahead and... So I'm going to put in here cucmpub.liketac.com. I'm going to put in my Axel username. And I'm going to put in my Axel password from Call Manager. I'm not doing TLS verify right now. I'm ignoring the TLS certificates because I don't have any certificates in play yet anyway. And then we will click Save. Okay, so my call manager was added with the FQDN. That's the requirement now that you don't have to have a UDS record. When the call manager publisher gets requested, it makes Axel queries and network queries. And if you had subscribers here, they'd be all listed here. And we can see the version of the call manager I have and the type of zone I have, a TCP connection. Don't have a TLS connection because I don't have certificates yet and have not configured TLS. Now let's go do that for our IMP servers and Unity servers. We'll go to Configuration, Unified Communications, IMP servers. We'll add an address. And my FQDN for the IMP is impub.liketac.com. I'll add my Axel user and password. I'm turning off TLS verify mode because we're not using certificates yet. And I'm adding the address. And I see my FQDN for the publisher. Names are there in the versions. And XMPP router is inactive right now, probably because it hasn't communicated yet with the Expressway C, or I haven't started that services yet on that server. We will return and fix that later. So to add the Unity servers, we'll go back to Configuration, Unified Communications, Unity servers. We'll add an address. The address is going to be cuc.liketac.com. That's my fully qualified domain for my Unity server. I will go ahead and add my Axel user again. I'll turn off TLS verify. Add the address. Now I see my Unity servers. I have the host name, and we have my version of Unity. Now all my UC servers are added to the Expressway C and can be discovered easily with the DNS records. Our next step in the DNS video here is to create some MRA Unified Communication Zones. We'll start out on the Expressway E. You'll go to Configuration, and then to Zones, and Zones. And right now you see all we have is the default zone. So we're going to create a new zone. We're going to call the new zone MRA UC Traversal Zone. And we're going to look at what kind of zone type it could be. It cannot be a neighbor zone. It cannot be the traversal client because that's the Expressway C. It's not the traversal server, although E is a traversal server, and it's not a DNS zone. It is actually the Unified Communications Traversal Zone. This is the zone where MRA devices will make requests to register and log in to Unified Communications. So we're going to give the connection credentials here. We're going to establish that we're going to use MRA user as an API user. We're going to add the password for MRA user by clicking here. We're going to make a new account, calling it MRA user. And we're going to give it a password. And we're going to create the credentials. Now we see that our user is now existing in the database. And it's right here under the Expressway E MRA zone. The same user and same credentials must be used by the C to log in to the traversal server. We're giving it port 7001, and the TLS verified name is the fully qualified domain name of Expressway C. We will see how that's going to be important in our certificates later, because that's what's going to do the verification. All the other settings are set to default. We come to the authentication section. We're going to change this from do not check the credentials to treat as authenticated, because we trust our MRA users to go across this tunnel. There's no other changes. We create the zone. Okay, the zone is up, and we note that there is a SIP status that's on, but no active connections, because we haven't really completed the configuration on the Expressway C side. So let's go over there and do that. We go to configuration, zones, and zones again. Here we see the neighbor zone going to the call manager with a CE TCP and a default zone. And we note there's no checkboxes next to it, because these are system generated and you cannot make effective changes against those zones. So we're going to create our new zone again. We're going to call it the same thing, MRA UC traversal, so everybody knows what that zone exactly is for. And again, we have our options here: neighbor, traversal client, DNS, and unified communication traversal. Again, this is where we're going to send all our registration and login requests from MRA devices. Now we see the connection credentials. This is the traversal client. Expressway C is going to try to log in to the traversal server, which we configured earlier on Expressway E with some credentials. We're going to put that username that we created, MRA user, and then we're going to add the credential that we add. Same port number. No changes to the defaults. Again, we're going to change it from do not check for credentials to treat as authenticated. Here's the peer name that we need to add. expresswaye.lightpack.com is our peer name, and then we're going to create the zone. And now we see the zone is created. Note the type of zone is Unified Communications Traversal, and it's MRA UC Traversal. And we see it's failed. And the reason why it's failed is because we don't have any certificates being enforced. And we can verify that by going down to the peer here. We note that the FQDN of Expressway E's A record has resolved by the C to the proper interface, 172.16.248, and the port number 7001, which is going to be our socket. But note the error, TLS negotiation failure. Let's go check that. If we put the FQDN that we are using as a TLS verified name on Expressway C, expressway-c.lightpack.com, we check the traversal certificates. We come back with the error server certificate, Tandberg, certs, server PEM, invalid because it has expired. Upload a valid certificate with a future expiry date. If we look at the security certificate, we note that it is expired, and it's only a temporary certificate. It's not actually using any kind of certificate that has a SAN that we can verify. We go to the Expressway E. We also look at the server cert there. It's expired. It's got that temporary expired cert. So we need TLS certificates to verify our zones. We can also download some diagnostic logs that I have running as I was adding the unified communication traversal zones. I'll stop my logging. I'll collect a log. I'll download the log. And it's saved in my downloads. I'll do the same thing on the Expressway E. Go to maintenance, diagnostics, diagnostic logging. Stop the log. Collect the log. Download the log. And it's in my download folder. Now that we have our logs downloaded, we can actually do some more further verification after we have done our due diligence on the web GUI. The web GUI told us that there's a TLS issue. We can verify this again with the Expressway logs too. I go to my Expressway C log, I go to the logging snapshot. And the best way to look for the errors in the log is with that port 7001. I do a Control F, 7001, and the significance of this 7001 is where the traversal client is going to try to connect to the Expressway E traversal server. I go to the first line in my debugs, and what I'm going to do is going to highlight this section of the log, and I'm going to color it for troubleshooting purposes. Now that I have it colored, I can examine this snippet of log. We see that the network TCP module is what we're interested in. We see that the source address is the actual address of Expressway C traversal client. The destination address is the IP address of the inside interface of Expressway E, 172.16.20.248, and our port 7001. We see a promising TCP connecting message going out, so the SYN's going out to the traversal server, Expressway E, and then we see the SYNAC and ACK as completed, and we see in the log a TCP connection established. However, the next line we see is outbound TLS negotiation error. SIP service was trying to establish the tunnel, so we see the source port, destination port, and it says something about self-signed certificate chain, protocol TLS, common name is expresswaye.liketac.com, so C is trying to send the information necessary to the Expressway E to get verified. Basically, it's saying, hey, Expressway E traversal server, here's the common name of the Expressway peer name that we put into the MRA zone. We said expresswaye.liketac.com. Expressway E, can you verify that for me, that this is good, and complete the TLS handshake for me, and establish a tunnel. Well, we see it doesn't. We see the TT-SSL error output shows that the TT-SSL continue handshake failed to establish SSL connection. Result is 1, which is true. Error is 1 is true. And if we continue to slide over here, we're going to see the local address and remote address for the expressways. And then we see an SSL reason error. The reason error says that the SSL routines SSL3 get server certificate chain verify failed. So basically, we sent the information over to the Expressway E, but E could not verify our traffic. And we can verify that with the Expressway E log. We go back to our diagnostic folders. We'll go into the Expressway E log snapshot. Again, we can look for that port number again, 7001. Find in the current document. And again, we see that we have a line that we can highlight here. And we see the same information. We see there's a network TCP module trying to work here on the traversal server side with the source of the C, the destination of the E, the TCP port 7001. TCP is connecting. TCP connection established. But then we go to try to verify our certificates. We see the detail TLS v1 alert unknown CA. The protocol is TLS. Then we again see TT-SSL continue handshake failed to establish the SSH connection. And then we see that the local and remote address and the SSL reason error, SSL3 read bytes unknown CA. So basically, we don't have a certificate to actually do any kind of verifications with. On our next video, we're going to generate some CSRs, get those certificates signed for Expressways, upload them to the Expressways, and do some more verifications to see that the tunnel will come up based on the SAN names and DNS names that we provided in the certificate. I hope this was informative for you, and please subscribe to Like Tech.